Hey, Mr. Herdum here. Time to go over solubility. How can we change how much and how quickly we dissolve? Well, first of all, you need to know what the term solubility is. Refers to the maximum amount of solute that will dissolve in a specific amount of solvent at a specific temperature and pressure. That's a great definition. Okay, factors that determine the rate. Now remember, when I'm talking about rate, this is speed, how fast it goes. Okay, and this is for solids and liquids. I usually think about sugar cubes versus granulated, as I try to draw a cube. Granulated sugar, which looks like that. Okay, so the first thing I try to do is I mix it, or I use a fancy word of agitation, of course. That's just a fancy word for stirring. Okay. Surface area. What you do is you increase the surface area. Granulated sugar has much more pieces of particles, I guess you're going to call them here, and each piece has surface area, as opposed to a sugar cube, which just has the outside. So it takes longer to dissolve a sugar cube than it does granulated sugar. And the third thing you can do here is you increase the temperature. And talking about making it go faster here. If I wanted to make it go slower, I would decrease the temperature. Okay, now we're going to talk about the amount of solubility. This is for either gases or solids dissolving in liquids. Okay, number one, the amount of solvent. If you have more solvent, you can dissolve more in it. So if you have more water, you can dissolve more salt in it. Okay. Number two, the infamous temperature, which is different for solids and gases dissolving in a liquid. If you increase the temperature for a solid, you're getting the particles to move faster, so they're going to dissolve faster. Because remember, solids just wiggle, 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 wiggle. If you don't understand what I'm saying. As they wiggle it. Okay. If you're talking about gases, remember gases go zoom, zoom, zoom. But solutions, remember, they're like semi-zoom like this. So you need to decrease the zoominess, and you can do that by decreasing the temperature for a gas. Okay. You don't heat up a soda to keep the carbonation in. You usually put it in a freezer to keep the carbonation in, to keep it cool. Okay? Pressure. Now pressure, whenever I'm talking about pressure, I'm only talking about gases. Okay? So if you increase the pressure of a gas, you're going to increase the solubility. That is Henry's law, actually. Believe it or not. Love Mr. Henry, just so you know. Gases and water, if you increase the pressure, the solubility increases. I already said that. Okay. When you open a can of soda, it loses the carbonation. Versus when it's closed, it keeps the carbonation. Okay. Describing the saturation of your solution. Okay. First of all, there is saturated. This contains the maximum amount of dissolved solute. Okay? Then there is unsaturated. This contains less of the maximum dissolved solute. I think of underground, so that's why I think it's less, because underground is less. And then supersaturated. and hopefully I will have time to make a supersaturated solution for you and show you how these work. These contain more than the dissolved solid, which doesn't make sense. Because how can you contain more than the maximum amount? To make a supersaturated solution, what you have to do is you actually heat up the solvent. So that way you can dissolve more in it. Then you can carefully cool it. Okay? And once you carefully cool it, it is a supersaturated solution. Okay? Which is very, very unstable. Usually if you add a particle to a supersaturated solution, it crystallizes. The whole solution crystallizes. So no longer do you have a solution, but you have a bunch of crystals. And hopefully I will be able to do that for you and show you how that works. Now, when I get to the next lesson, when I talk about saturated curves and solubility curves, saturated curves, who uses that term? Hello, it's a solubility curve, Mr. Harridan. Use your terms properly. Solubility curve, which is the next lesson after this one. You can determine if your solution is saturated, unsaturated, or supersaturated. If the solution is saturated, the dot is on the line. No, bring back on the line. On the line. Okay. If it is unsaturated, the dot is below the line. That was my underground reference to you because the dot's below the line, just like underground is below the ground. Okay. If the dot is above the line, okay, it is super saturated. Like Superman flies in the sky, you've seen Superman, right? You know, Christopher Reeve. I don't even know who the new Superman is. Somebody's going to have to tell me who the new Superman is. Okay, now let's look at example 12.2 here. 4 solutions were made of 100 milliliters of water dissolving various amounts of NaCl. Adding 30 grams of NaCl was added to the solutions. The solutions were stirred for 5 minutes and the results were recorded. Classify the original solutions as saturated, unsaturated, and supersaturated. Oh boy. This looks like good fun. Let's look at solution number 1 here. We added 30 grams and 0 grams of sodium chloride are at the bottom of the container. So here we can tell that this all dissolved. Okay? Since this all dissolved, that means there was room for it, which means that the solution was originally unsaturated. Okay. Solution number 2. 30 grams was added. I can tell that none dissolved. How do I know that none dissolved? Because 45 grams are at the bottom of the container. Okay? Which means more fell out. If more fell out, that says more fell out. I know you can't read it because it's really small and you're probably watching this on your phone, but it says more fell out. That means that this is a super saturated solution. Okay. Number 3, okay, we added 30 grams and 30 grams is at the bottom of the container. So none dissolved. And all fell out. That means that we were at the saturated point and we cannot get any more in unless we were to heat the solvent and then carefully cool it, making it a supersaturated solution. Okay. 30 grams, 10 is at the bottom here, so here we had some dissolve. And we had some didn't. Okay. So the original solution was unsaturated, and then you ended up with a saturated solution. So if you can dissolve any more into it, it is an unsaturated solution. If the amount you try to add and the amount that is at the bottom are the same, it's a saturated solution. And then if you add less, but there's more at the bottom, it is a supersaturated solution. That is what I've concluded from this lesson. Okay, you guys are champions. The legend is out.